Bonjour, geologists, and welcome back to our second video in this very quick crash course in geology. I'm trying to get through all of Unit 4 before we go on winter break, which is in less than 10 days. So thank you for hopping on in to watch this video. After we watch this video, there are 5 to 10 questions in Google Classroom that I would love for you to answer with your best intent. In our last video, we talked about Alfred Wegener, who pondered and thought, hey, this looks like this could fit with this, and there's fossils found all along these, and maybe our continents where we live are slowly moving. Studied a little bit about plate tectonics and the crust, the core, and the mantle of our planet, and how all that bubbling and churning of magma might be moving our continents slowly over years to change how our Earth looks. Well, beyond Alfred Wegener's theory, we have more evidence that our Earth is changing, that it is changing shapes, both vertically, up and down, deeper trenches, taller mountains, and how our continents are shaped. And we're going to find that all out today in Unit 4, Chapter 2, more evidence of Earth-shaping processes. First thing I see, beyond Monument Valley, a beautiful trademark of all Western films, here in northern Arizona, we have that big question. Our big question that we want to ponder and think about for today is what evidence shows that Earth's surface has changed over time? Where is our proof? How do we know this? Well, let's see what other perspiring geologists have come up with as their evidence, their proof for this theory. Okay, so below our picture of Monument Valley, we have this caption: over millions of years, layers of sediment eventually became solid rock. Then some of it eroded away to form the monuments of Monument Valley. Okay. The rust-red landforms of Monument Valley in Arizona are amazing to see. These structures are called buttes and are made of different types of rocks. When people first came across these buttes, not buttes, buttes, they wondered how they formed. They asked many questions. Why are there different kinds of rocks stacked in matching layers from one butte to another? Did these formations always look like this? Well, geologists, the people who study Earth and the rocks that make it up, look at the types of rocks that are present in an area to figure out how the Earth's surface has changed and how it might change in the future. Monument Valley's buttes are evidence that the valley was not always there. The different layers are evidence of the types of rocks that completely filled the valley long ago. So you'd be whole a range of rocks. You wouldn't see those buttes, you just know that there was layers of rocks that whole time before it was all eroded away. So, those different types of rocks, 3 types of rocks that we have here on planet Earth. We have sedimentary, igneous, and metamorphic rocks. And we do go into these because as much as I am not my brother, I didn't go out and collect all the shiny rocks that I could find, I still thoroughly enjoy saying sedimentary, igneous, and metamorphic rocks, and we will go over this more even beyond this 1-week crash course into geology. Geologists study rocks to understand Earth's history. Geologists categorize types of rocks based on patterns. These patterns tell how the rocks formed in the past. Our first vocabulary word is sedimentary. A sedimentary rock is a rock made of sediment that is compacted together. Well, I don't know what sediment is. Well, let's read on to figure out what that word means to get a better picture of what a sedimentary rock might be. Sedimentary rock is made of sediment, or bits and pieces of other rock that are compacted together. Sediment settles out of water. It's deposited by wind or it is moved by glaciers, large moving sheets of ice. One example of sedimentary rock is sandstone or limestone, which you probably have if you have a pool in your backyard, or you can see real close if you look up to South Mountain. It is a lot of sandstone compacted and pieced together over millions of years. It is made of sand grains that are cemented together by pressure. Another type of sedimentary rock is shale, which is made of very tiny compacted sediment grains. Layers of sedimentary rock tend to form in places where wind, ice, or water break down larger pieces of rock into smaller pieces. So here we have a picture of the Rocky Mountains that used to be larger. Those look like pretty massive mountains, but they used to be larger, and now they are breaking down, and the sediments are carried away by water, wind, and glaciers into rivers such as the Salt River or Colorado River, and it brings all those sediments further down to places like Phoenix. So sediments, if you've ever picked up a rock, a sedimentary rock has layers. You can see that it's a lot of distinct layers. And that's just the sediments pressing down over time, collapsing to form a bigger rock. All right, next up we have igneous rock, and an igneous rock is a rock made of magma or lava that has cooled and hardened. So igneous are the freshest rocks. They're straight from the lava, straight from the magma, have not been changed. Sediments have been broken down over time and layered and layered and layered and layered till they formed new rocks. And metamorphic, which we will read about on this page, is a rock that forms when igneous or sedimentary rocks are placed under tremendous heat or pressure. So over a long, long time, your fresh igneous rocks that blasted straight out of a volcano, or your sedimentary rocks that have been layered and layered and compressed, those sometimes get buried down underneath and further and further and further into Earth's crust, where they come close to the mantle, that mantle of hot, bubbling, churning magma. Well, that will heat and melt down those rocks to form different rocks. If you have marble counters at home or granite, these are examples of metamorphic rock. They have gone through a metamorphosis or have changed, kind of like a butterfly in a cocoon, but a rock, and billions of years of people pressing down on them. Also how you get diamonds. But without further ado, let's read on to this page. The rock that comes from Earth's interior and is cooled is called an igneous rock. There are different ways for igneous rock to form. One way is when molten lava erupts out of a volcano. Other igneous rocks form when magma intrudes into Earth's crust but remains stuck there under pressure. The slower cooling process makes different patterns of minerals that show up as visible grains. Granite, which I misspoke, is not metamorphic, it is igneous. People make mistakes, you know that. Granite is an example of an igneous rock formed in this way. So usually you might see distinct, here's a shiny bit in this overall rock. Sediments are a lot of clear layers. Igneous might have imperfections or crystallizations from the overheating of the magma or the lava erupting. Both igneous and sedimentary rocks can, not always, but they can, change into the third type of rock called metamorphic rock. This occurs when heat and pressure change those rocks into a different form. Marble, I was right on that, is an example of metamorphic rock. If you take granite and you put it under even more pressure, it becomes marble. All those nice smooth swirls, it's all that pressure pushing down on it. Okay? So here's a marble quarry. It was a sedimentary rock called limestone. Granite, marble, not the same. Marble is limestone. Learn something new every day, even when you've been teaching 4th grade for so long. But marble is frequently used for your famous statues. All right. We find fossils in sedimentary rocks. Those layers upon layers upon layers upon layers, they can include fossils. Fossils give us evidence that this used to live a lot closer to this, just like we talked about in our last chapter. Throughout the middle of the United States, the fossils of sea creatures have been found. Even here in Arizona, we find fossils of sea creatures. Arizona's not a sea. We don't have water. We're a desert. Well, these are often found in deserts or very dry areas, far from the nearest ocean. Why are there fossils of sea creatures found in such places like Arizona? Well, geologists explain the discovery of these fossils this way. The central part of what is now the United States was actually covered by a very large sea about 75 million years ago. The sediment that accumulated at the bottom of the sea became sedimentary rock. Some of the organisms that died in the water left remains that settled into the sediment. Sediment moved by wind and water became layered on top of dead organisms. Their fossils can be found in sedimentary rock today, in states far from the ocean, such as Montana, South Dakota, or Arizona. And this is what it could have potentially looked like with a giant sea running straight through the middle of what is now known as the United States. Comparing rocks. Which rock is bigger, smaller, prettier, uglier? Scientists such as you and geologists like to compare rocks. Well, we remember the buttes of Monument Valley, each butte is made of layers of rock laid down at different times. Different buttes sometimes have the same layers running through them. At one time, the buttes were all part of a single strip of land. But over time, forces wore parts of the rock away, leaving the buttes behind. Then some of the buttes wore away at different rates than others. So it used to be one giant loaf of rock that has been broken down and eroded either by wind or rain or ice in some way. Well, examine the buttes in this picture. Well, what do we see? Notice how similar the rock layers are in each. Both buttes have layers with the same thickness and color. That's because they were once a single strip of land. But over time, weather wore away the part between them, leaving the individual buttes. And this, I believe, is closer to Sedona, Arizona. If you've ever been, you'll notice all these beautiful red and purple rocks, although all used to be all part of one mountain or strip of land. When geologists find similar types of rock in two different locations, they can draw conclusions about what happened to make the different locations look so similar. The Appalachian Mountains in North America and the Caledonian Mountains, which are scattered across the northern part of the British Isles in Scandinavia, have identical rock types and overall shapes. What could cause this to happen? So North America, we have the Appalachians. Up in Europe, we have the Caledonian Mountains. Well, we know buttes used to all be one part, but buttes are usually closer together within 5-10 miles. Here we're talking about two separate mountain ranges that are thousands of miles apart, just like fossils that looked a lot alike thousands of miles. Let's continue reading on. Well, Alfred Wegener wondered the same thing. He examined rock types and land forms in different locations around North America, Africa, and Europe. The mountains of these now distant locations seemed to match up in terms of the rock types and the continental outlines. To Wegener and other scientists, this was evidence that the mountains formed in one place and then were separated as the continents drifted apart. Not like Tokyo drift and swerve around the corners, but the continents are moving away from each other. If two locations that are not very far apart have similar rock, like our buttes, but one location is missing one or more layer, geologists might conclude that some process has changed Earth's surface over time. So sometimes one might have a layer that another one doesn't, and we have to figure out how one changed and the other didn't. Well, to understand that, we briefly need to know how mountains are formed. So we've got these interesting, cool little folded rocks here. Folded rocks are evidence of change. Some kind of force was applied to fold the once flat layers into beautiful, wavy formations. As with mountain building, these forces can take thousands to millions of years to form folds. See how we've got different layers in the sedimentary rock and how they kind of have that nice little swirl. It took thousands of years because something was changing. Well, some types of mountains form when parts of Earth's crust push against each other. Earth's plates can meet and push against each other. Both plates may be forced upward, or one plate will slide beneath the other, pushing the top plate up. These are ways mountains form because Earth's plate moves so slowly, it may take thousands to millions of years for mountains to form. At the beginning of this chapter, we talked about evidence, that proof that scientists have of explaining all of this. Well, let's look at some evidence of some major events. Rocks and rock layers can provide evidence of other major events that change Earth's surface. Consider this evidence from the rock layers. Evidence of causes for dinosaur extinction. Dinosaur fossils have not been found in rock layers that are younger than 65 million years. The size and different types of fossils from this period drop sharply as well. This evidence tells scientists approximately when the dinosaurs died. A huge crater is discovered in rock layers in Mexico. This evidence supports the idea that a large asteroid struck Earth. The impact caused shock waves, fire, large waves, and climate change that made it difficult to live on Earth. Iridium, a rare element, is found in abundance in layers of Earth's rocks from around the same time as the extinction. It is more common in meteorites than in Earth's rocks. The iridium layer is evidence that a large meteorite struck Earth 65 million years ago. Okay. Evidence from the rock layers show that most large animals on Earth died off in a very short period, that a large asteroid struck Earth around the same time, and that dust from the impact was thrown up into the atmosphere. All three pieces of evidence lead scientists to propose that a large asteroid struck Earth around 65 million years ago, resulting in the extinction of dinosaurs. As sad as that may be, it's probably for the best that we don't have a bunch of dinosaurs running around anymore. But our Earth is constantly changing, whether it's asteroid strikes, erasing all of the dinosaurs, whether it's the Earth moving, the bubbling, churning magma that heats up and spits out igneous rock, the layers and layers and layers and layers and layers and layers and layers of sedimentary rock, or the pressure that pushes down either igneous or sedimentary rock to make metamorphic rock. Our Earth is constantly changing, and it is constantly fascinating. I know we are doing this as quickly as we can with only 1 week to crash course through 7 chapters of geology. It is fun. It is fascinating. We will do more with it once we return from winter break. But I hope you enjoyed this video. Stay awesome, and I will talk to you real soon.